In this video, we'll discuss converting between pH and pOH. pOH is similar to pH, but it expresses the concentration of hydroxide instead of hydrogen ions. It ranges to between 0 and 14. It's inversely related to the pH scale. So if you have a 0 on the pH scale, that's a 14 on the pOH. If you have a 14 on the pH scale, that's 0 on the pOH. So converting between pH and pOH, as simple as it gets, pH plus pOH is 14. It's that simple. If you know the value of one of these, you can solve for the value of the other. Now, if you want to solve for hydrogen ion concentration or hydroxide ion concentration, it's a different equation. So in this equation, we have the hydrogen, or even you could say the hydronium ion concentration times the hydroxide ion concentration is equal to the K value for water. Now, the K value for water is always 1 times 10 to the negative 14. So let's look at an example. The first example is going to be the easier of the two. We have a pH of 3.81. We want to calculate the pOH. Well, it's really simple, right? We just have this simple equation, pH plus pOH gives you 14. You're going to solve for the pOH by subtracting pH. Substitute the number, so our pH is 3.81, subtract, that gives you 10.1900, on and on and on. But sig figs, right? So we're adding and subtracting. Well, we're subtracting here, so the rule is decimal places. We have 2 decimal places, so our answer has to have 2 decimal places. In the next example, we know the hydronium ion concentration is 7 times 10 to the negative 4, and we're calculating the hydroxide ion concentration. We have our equation. We're going to isolate the variable we're looking for, which is the hydroxide ion concentration. We're going to plug in our hydronium, which is given to us 7 times 10 to the negative 4, and you just divide. When you divide, you get 1.3 times 10 to the negative 11th. But sig figs, right? We have 1 sig fig in the beginning, so we need 1 sig fig, 1 times 10 to the negative 11th.